Pure water is a very poor conductor of electricity. However, even small amounts of impurities like dissolved salts, minerals, or other contaminants can significantly increase its conductivity. These impurities act as ions, charged particles that move freely through the water and carry electrical current. When a person is wet or standing in water, these impurities, along with the body's natural electrolytes, lower the overall resistance of the path between the electrical source and the body, making it easier for current to flow. This reduced resistance increases the likelihood of an electrical shock or electrocution. Imagine a container filled with pure water. If you insert a pair of electrical probes into the water, you will observe very little current flow due to the water's high resistance. If you use tap water instead of pure water, you will notice an increase in current flow because tap water contains dissolved minerals and other impurities that act as ions and enhance conductivity. If you dissolve a significant amount of salts into the tap water, the conductivity will further increase due to the abundance of ions present in the solution. The human body contains electrolytes such as sodium, potassium, chloride, and bicarbonate ions, which make our tissues and fluids reasonably good conductors of electricity. When a person is wet or standing in water, the presence of these electrolytes in the water further reduces the resistance between the electrical source and the person's body, increasing the risk of an electrical shock or electrocution. While pure water is a poor conductor, the presence of impurities and electrolytes in water, combined with the inherent conductivity of the human body, can make wet conditions much more hazardous when dealing with electricity. The lower the resistance, the greater the current flow for a given voltage. Ohm's law states that current is equal to voltage divided by resistance. Therefore, any reduction in resistance results in an increase in current if the voltage remains constant. Electrical codes, such as the National Electrical Code, provide guidelines for safe wiring practices and equipment usage to minimize the risk of electrical shock in both dry and wet locations. Ground fault circuit interrupters, or GFCIs, are designed to detect even small amounts of current leakage to ground and quickly interrupt the circuit, providing protection against electrical shock. These devices are particularly important in wet locations, where the risk of electrical shock is higher. When working with electricity, it is essential to always follow safe work practices, such as wearing appropriate personal protective equipment, to energizing circuits before working on them, and using properly insulated tools. Regular inspection and maintenance of electrical equipment can also help to prevent electrical hazards. Understanding the principles of electrical conductivity and resistance, as well as the safety measures in place to protect against electrical shock, is crucial for anyone working with or around electricity. The effects of electrical shock on the human body can range from mild tingling to severe burns, cardiac arrest, and even death. The severity of the shock depends on several factors, including the amount of current flowing through the body, the path of the current, the duration of the shock, and the individual's overall health. Even a relatively small amount of current can be dangerous, especially if it passes through the heart or brain. That's why it's so important to take precautions to avoid electrical shock, especially in wet conditions. In addition to the presence of impurities and electrolytes in water, other factors can also increase the risk of electrical shock. For example, the type of surface a person is standing on can affect the resistance of the path to ground. A concrete floor, for instance, is typically more conductive than a wooden floor. The presence of metal objects in the vicinity can also increase the risk of electrical shock, as metal is a good conductor of electricity. It's also important to be aware of the potential for static electricity to cause electrical shock. Static electricity can build up on the surface of objects, particularly in dry conditions, and can discharge suddenly when a person comes into contact with the object. While static electricity shocks are typically not life-threatening, they can be uncomfortable and can potentially ignite flammable materials. Therefore, it's important to take precautions to prevent the buildup of static electricity, such as using anti-static sprays or grounding straps. When working with electrical equipment, it's also important to be aware of the potential for arc flash. Arc flash is a dangerous phenomenon that occurs when a short circuit creates a high-temperature arc of electricity in the air. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash, electrical workers should wear appropriate personal protective equipment such as flame-resistant clothing, safety glasses, and gloves. They should also follow safe work practices such as de-energizing circuits before working on them and using properly insulated tools. Electrical safety is a critical concern for anyone working with or around electricity. By understanding the principles of electrical conductivity and resistance, as well as the safety measures in place to protect against electrical shock and arc flash, we can minimize the risk of electrical hazards and ensure a safe working environment. The National Electrical Code, or NEC, provides comprehensive guidelines for safe electrical installations and practices. It covers a wide range of topics, including wiring methods, grounding and bonding, overcurrent protection, and equipment installation. Adherence to the NEC is essential for ensuring electrical safety in buildings and other structures. Many jurisdictions have adopted the NEC as law, making it a legal requirement to comply with its provisions. Even in jurisdictions where the NEC is not legally mandated, it is still considered a best practice to follow its guidelines. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It is important for electrical professionals to stay up to date on the latest edition of the NEC and to understand its requirements. In addition to the NEC, other organizations, such as the Occupational Safety and Health Administration, or OSHA, also provide guidance on electrical safety in the workplace. OSHA standards require employers to provide a safe working environment for their employees, including protection from electrical hazards. Employers must train their employees on electrical safety procedures and provide them with the necessary personal protective equipment. Failure to comply with OSHA standards can result in fines and other penalties. Electrical safety is not just the responsibility of electrical professionals. Everyone should be aware of the potential hazards of electricity and take precautions to avoid electrical shock. This includes using electrical appliances safely, avoiding contact with overhead power lines, and reporting any electrical hazards to the appropriate authorities. Education and awareness are key to preventing electrical accidents and ensuring a safe environment for everyone. The information I have given underscores the importance of recognizing that while pure water itself is a poor conductor, real-world water sources invariably contain impurities that dramatically increase their conductivity. This, combined with the human body's own conductive properties due to the presence of electrolytes, creates a significantly heightened risk of electric shock in wet environments. The demonstration involving pure water, tap water, and salt water effectively illustrates how the concentration of ions in water directly affects its ability to conduct electricity. This principle is fundamental to understanding why even seemingly small amounts of water can pose a serious threat when electricity is involved. The human body's reliance on electrolytes for various physiological functions makes it inherently conductive. When the body is wet, the water bridges the gap between an electrical source and the skin, reducing resistance and allowing current to flow more easily through the body's tissues and organs. This is why even low-voltage sources can be dangerous in wet conditions. Electrical codes and safety regulations are designed to mitigate these risks by requiring the use of ground fault circuit interrupters, or GFCIs, in areas where water is present. GFCIs monitor the current flowing in a circuit and quickly trip the circuit if they detect any leakage to ground, preventing electric shock. Regular inspection and maintenance of electrical equipment are also crucial for preventing electrical hazards. Damaged cords, frayed wires, and corroded connections can all increase the risk of electric shock. It is important to replace any damaged equipment immediately and to ensure that all electrical connections are properly tightened and protected from moisture. Furthermore, it is essential to educate people about the dangers of electricity and to promote safe work practices. This includes teaching people how to identify electrical hazards, how to use electrical equipment safely, and what to do in the event of an electrical emergency. By raising awareness and promoting safe practices, we can reduce the number of electrical accidents and injuries. Remember, electricity is a powerful force that can be both beneficial and dangerous. By understanding the principles of electrical conductivity and resistance, and by following safe work practices, we can minimize the risks associated with electricity and ensure a safe environment for ourselves and others. The key takeaway is that while pure water is a poor conductor, the water we encounter in our daily lives is not pure. It contains impurities that make it conductive, and this conductivity, combined with the human body's own conductive properties, creates a significant risk of electric shock in wet conditions. Therefore, it is essential to take precautions to avoid electrical shock, especially in wet environments. Always use GFCIs in areas where water is present, regularly inspect and maintain electrical equipment, and educate yourself and others about the dangers of electricity. By following these steps, we can minimize the risks associated with electricity and ensure a safe environment for everyone.